And let's take a look at 21, 22, and 23. I think this is where I feel you guys have problem with, which is the expected value. So they say that a 25 years old can purchase a 1 year's life insurance policy for $10,000 as a cost at the cost of $100. The past history indicates that the probability of a person dying at the age of 25 is 0.0015. Determine the company expected gain or loss per policy. So again, we are trying to find the company gain or loss, not the customer, right? So looking at this thing here, if you remember, if you see the word expected gain or expected loss, if you remember what we did in class, on our meeting was I set up a chart, right? I set up a chart. I told you guys that we need this chart. We need an amount of gain and amount of loss, right? Which is, again, in terms of this thing here, everybody see that the amount of gain, the company, when they sell this policy, the company gain $100, right? And again, the loss, if they have to pay out, they have to pay out 10,000, but everybody say that they not really pay out 10,000 because they took your $100 in beginning, so they pay out 99,900, right? Which is, again, not the 10,000, which is, again, and again, what is the probability of their loss? Meaning, what happened if I were to buy this life insurance and I die, right? They have to pay my family this much, not me, because I'm dead, right? What is the probability of me dying here, which is the probability of me dying at the age of 25 is 0.0015, right? Which is 0.0015 here. Remember, the total probability, you probably say, where did I get the 99.85 come from? Because the total probability is 100 or 1, right? So if I know that this item is 0.0015, just imagine that your bell-shaped curve, right? If we know that the small portion is 0.0015, what is the leftover? Which is we take 1 minus that item, which is 0.9985. Everybody see that? And then again, what we do was we multiply, right, the 100 times the probability, the negative 9999900 times the 115 or 0.0015, and then we add them up, or in this case, we subtract them, which is, as you can see, with this item, the company, the insurance company, gain $85 per customer whoever buy at the age of 25, right? If the year go by and you survive to 26, they get that $100, right? If somebody die at the age of 25, they pay out, but again, they already took 100, so they only pay out 9,900. So this is what we did, or this is how we did it, or this is how I want to connect with the expected value item. Whoever took the test, or if you did the homework online on Alex, they show you the other way. The other way is, if you don't want to deduct the gain and the loss, right? This is what they tell you is, if you don't want to deduct the gain or the loss, basically you take whichever the gain or the loss that the company have, multiply to the probability, right? In this case, because of the loss, because of again, what probability did they give you, right? We don't know the gain probability, but we know the loss probability. Everybody see that the company will lose 10,000, and the probability of the company lose 10,000 is 0.0015. Right? So, this thing here, they just tell you that whatever probability they give you, take the probability times the amount that associated with that probability, right? So again, is the 0.015 is associated with the 10,000 or associated with the 100, right? So again, this thing here, if they die, they will lose this much, which is they tell you to take this item here and add to whatever you don't have the probability of. So this case here, we don't have to deduct the gain or the loss. We just go straight forward. Whatever probability they give you, times those corresponding number, and then add whatever left. which is, again, if you do this way, is the same idea, which is 10,000, negative 10,000 times 0.0015 will give you negative 15, and negative 15 plus 100 will give you 85, which is the same number you have, which is the company expect to gain $85 per policy. Okay, that's what they expect to gain, and again, that's how they stay in business, right? They have to gain something to stay in business for the insurance, right? So again, that's the idea. Or let's try one more. That problem is a little bit, you probably say, wait a minute, how did I came up with that probability, and how does that probability associate with the 10,000? Let's take a look at this thing here, which is, again, let's attack this problem like Alex, right? The way Alex attacked this problem. So a game is played using one dice. If the dice roll and show a number 2, the player win $8. If the dice show number 3, the player win $4. If the dice show any other number, the player lose $3, right? So again, it's the same idea I have for you before, and I did the chart for you guys before, but let's take a look at this thing here, which is, do you agree that in order for me to win $8, right, the player, which is I'm a player, in order for me to win $8 is have to land on number 2. How many sides on my dice have contain number 2, which is I have 1 out of 6, right? And in order for me to win $4, it's actually number 3, which is I have 1 out of 6 again. It's not 3 out of 6. I have only 1 out of 6. One side contain number 3 divided by 6 sides. I don't have the probability of losing $3, so again, that's my $3 here. Minus the $3. Why minus $3? Because that's my loss. I have to pay the fee, right? So looking at this thing here, all I did was I take this item and I multiply, which is 8 times 16 to give me 1.33. 4 times 16 to give me 0.63 minus the $3 that I spent. Once I have this thing here, as you can see, if I add them up, I will get a negative 1. Okay, which is in order for you to play this game, you should expect to lose $1 for every $3. The difference between this method and my method is my method, instead of say $5, we have to convert it to $8. I'm sorry. Instead of say win $8, I convert to only $5, because you only win $5, you only gain $5, right? So again, depending on which method you like. I don't know. Some students like this method. Some students like my chart. So again, the reason I did not type the chart here is because I feel that I typed the chart before. You can look at the chart before, and I just want to attack this problem this way. So whoever wants to attack this way, you can. You don't have to multiply the one number, the amount, by the probability, right? So same thing goes. Let's take a look at this last item here, and then I take any question you might have. A service that repair television sell a maintenance agreement for $10 a year, just like Netflix, right? Just no. The average cost for repair a television is $34, and 5 in every 100 people who purchase the agreement, have television require repair. Find the service expectation profit per maintenance agreement. So look at this thing here. What are they giving us, right? We are looking for the maintenance argument, right? Maintenance. So do you agree that they gain $10 in terms of the per agreement?